Hello! Welcome everyone to my talk at the virtual JupyterCon. I'm really excited to be part of this and to share something with all of you. I hope that we can have the same sort of interactions that we might get at the actual JupyterCon under these circumstances. So if you enjoy the talk, feel free to reach out. I'd love to talk online in any way that we can. I am Peter Bull. I'm one of the principal data scientists and a co-founder at Driven Data. We are a data science consultancy that runs machine learning competitions for nonprofit organizations and does data science projects with those same groups. So let me share a little about my qualifications for this talk. First of all, I use Github for work. And here's the nice graph of my commits for the last 6 years. What's the point in having these graphs if you never get to show them off to anyone? And our team uses GitHub, but the processes and tools that I talk about are really about collaboration with Jupyter Notebooks generally. And even though parts of it I'll go through GitHub, it is not specific to GitHub. I do most of my work in Python. And I've been doing that for the last 12 years. And it's the case that some of the tools will be specific to Python. And if you're part of the Julia or the R ecosystem and that part of Jupyter, then I'd encourage you to submit pull requests to these tools so they can work for you as well. And I'm a long-time Jupyter stan. I've been working with Jupyter Notebooks for let's see, this commit is adding a SciPy integrator to a notebook, and that was back in 2013. So at least that long, however that is. And then finally, and most importantly, I really like working with other people, and I want to collaborate with other people, and I want to do so using Jupyter Notebooks. And that's really what sets up the problem that we saw at the start of this presentation. So what am I going to talk about? I'm going to talk about the search for the Grail, a GitHub process for Jupyter Notebooks that just works. But this is probably more accurately a GitHub process that works well for our team of data scientists who do a lot of collaborative work in Jupyter. But I hope that it provides you some tools and some processes that you can bring back to your own organization, to your own team, and use them as well. So the first question we always ask is, why do we care? Why do I want to solve this problem that we set up at the beginning of the presentation? And the most important reason for Driven Data and for me is code review. When I started as a software engineer, the amount that I learned going through a code review process was orders of magnitude more than I learned when I was trying to teach myself something. And I learned some tricks and some craftsmanship and some tools of the trade that you just don't get if you're trying to teach yourself without someone who's really given you mentorship. So we try to practice that at Driven Data for a number of reasons. First, because it lets you really flex a muscle that a lot of programmers don't practice. But if you talk to really expert engineers, they say it's one of their most valuable skills, and that's the ability to read and understand other people's code. A second set of eyes is especially important for data science work. Having someone take a look and say that something makes sense or doesn't is really critical, because when you're doing data work, not all of your errors are allowed. It's not the case that your code will just not run if you've introduced a bug. If you've taken the mean instead of the median, you're never going to get an error in your code. It really requires someone thinking about what's happening to catch that class of error that's more and more common in data work than it is in engineering work. And at Driven Data, we don't have any code that makes it into any of our outputs, whether that's just a plot that's going to be in a presentation or a summary statistic that's in a report, or any software that we're putting into production without code review. So that's why I think code review is really the most important reason to care about collaborating around Jupyter Notebooks. So let me give you a big picture overview of what our process is And then most of this presentation is going to be a demo of how this works and how we use these tools. So first, we have a consistent project structure. We use cookie cutter data science, which is an open source project template that Driven Data created and maintains. We have an internal convention for how we name our notebook files. And this helps us prevent having conflicts between people. And also, it gives us a way to reasonably reconstruct the process of analysis that happened. And I'll talk a little bit more about that when we go through the demo. Third, we refactor pretty aggressively when we're working collaboratively on a project. And we take code that was in a notebook that was solving a particular problem in one place, and anytime we need to use that in another notebook, we factor that out into a Python module so it can get managed like a normal piece of source code. And that makes it a lot easier to have high quality code that is used throughout your project without having it living only in notebooks. Fourth, we have a tool called NB Auto Export that will take a notebook and automatically create the equivalent .py file that is just the code that's in the notebook. And we track those side by side with our notebooks so that we can use that for doing code review. And that's what I'll demo to you later in this presentation. And finally, I'm going to share a couple of other neat little things along the way about automated execution and Git hooks and code formatting and some particular things that we do on GitHub that I hope will be helpful and interesting. So without further ado, it's demo time. All right, so let's get this demo started. Here I've got a list of wildfire incidents. And what we're going to do is, if you look at each of these incidents, you can see that we've got sort of a summary of the event that's happening, some narrative, and then we have text with a bunch of information about this. And this is, if you're in the United States, and especially on the West Coast, you'll know this is a particularly relevant problem right now. And we want to understand better the different dimensions of these wildfires and see what we can learn from scraping this data and analyzing it. So that's the project that we'll be doing for this demo. Now, whenever we start a project, we start with cookie cutter data science, which is a data science project template. And the reason we use this is that means that everyone on our team knows where every component of a data science project should live. So let me get this started here. I already have cookie cutter installed in my base environment, so I don't need to do this first step, but I'll just do this step to start a new project. So that's cookie cutter and then the path to the repository that I want to use as a template. You can see I've done this before. So for my project name, this will be Wildfire Tracker, and I'll accept that as my repo name as well. I'll put my name in as the author, and then a short description of the project. And I'll select MIT as my open source license. And I won't do anything for AWS right now. And we are living in a Python 3 world. It's a wonderful thing. Once cookie cutter has run, I can see that it's created a wildfire tracker folder. And that folder has a bunch of pre-created folders for the project structure, for data, documents, notebooks, most importantly, and code. So let me show you what that looks like in an editor here. I've got all of those folders, my data folder, my notebooks folder doesn't have anything in it yet, and then a handful of other useful generated files like a README. And you can look at the cookie cutter data science documentation to learn more about how to use cookie cutter in particular. So let's say I know what requirements I'm going to use for this project already. I can add them to my requirements.txt. In this case, I definitely want Jupyter and IPython, NB Auto Export, which I'll be talking about, and then pandas for analysis, plotly for plotting. So let's go back to the terminal. And let's do make create environment. Oops, let's actually move into our wildfire tracker directory first. And now let's do make create environment to make a new Conda environment that we can use for this project that doesn't have anything else in it. And at Driven Data, we create Conda environments for every project that we do so that we don't have a mess of dependencies that we need to track across projects. So now you can see I'm in the wildfire tracker Conda environment, and I've edited my requirements.txt to add those. So I can do pip install -r requirements.txt, and pip will go out, get those packages that I need, and install all of them. One of the packages that pip is installing is nbautoexport. And what nbautoexport does is when you save an IPython notebook, it exports just the code portion of that notebook as a Python file and saves that as well. So every time you hit save in a notebook, you ended up with the saved script version as well. And you can do this with the HTML version or the Markdown version if you want those. But we generally use it for the Python version so that we can track that in source control. So let me show you how to make nbautoexport work. First thing you want to do is install nbautoexport. So now that I have the package, I could run nbautoexport install, and it says post-save hook successfully installed with Jupyter. And if you want to know where that's installed, you can run Jupyter --paths, and this tells you your configuration paths. And you'll see that my top config path here is in my home folder and then in the .jupyter folder. So I can take a look at the notebook config in that folder. And if we look at that file, we'll see that nbautoexport has added a block of Python code that will replace Jupyter's normal post save with the nbautoexport post save. And it will actually just modify post save. So if you have post save doing something already, it will continue to do that. It just adds this nbautoexport version as well that will do the export based on whatever your configuration is. So you only do that once, and now this is on my machine for as long as I want it to be. And what we can do now is configure nbautoexport for this project. So because everyone on the team uses nbautoexport, I'll run nbautoexport configure here. So nbautoexport takes a directory, in this case, I want to pass it notebooks, where you want it to be configured. So I'll configure notebooks, and what that does is produce a file in notebooks called .nbautoexport. Let's take a look at that file. That file says I want to export the script format, I want to organize my files by extension, and I don't have any particular clean parameters here. And you can see this is by extension, saying we want to keep the script ones separate. But another thing you could do is you could organize your notebooks by notebook, like we do in this example here, where it takes the name of the notebook, uses that as a folder, and then stores the file in there. So it's up to you how you want to configure nbautoexport. So let's actually run Jupyter Notebook now and see what this does. So I'll run Jupyter Notebook in the Notebooks folder. And that will actually open the Jupyter server. And I'll start a new notebook here. So I want to take a quick moment and talk about naming a Jupyter notebook. We have a convention that we follow at Driven Data that makes it especially easy for us to work together. And that is we preface the notebook with a number. And that number is usually of the form 0.0, 0.1, 1.0, 2.0, 2.1, etc. And the reason that we do that is we have a standard process where 0 is for data cleaning, 1 is for data summary and exploration, 2 is for any visualizations that we might want to do, 3 is for modeling, and 4 is for evaluation that you might do after building a machine learning model. So generally, we have a sense for what kinds of things are contained in a notebook if we preface it with a particular number. So here, I know that I've actually got the data already, and so I will start with 1.0 since there aren't any other 1.notebooks. And then another thing that we do is we always put our initials right after the notebook number just to indicate who worked on this. Now, you don't have to do that. We just found that it's been nice to be able to go to the person that wrote a notebook and ask them how exactly something works if we don't understand it when we're reading it. So I'll put my initials there, and then I will put summary statistics. So that will be the name of this notebook. And what I'll do is I'll do import pandas as PD. I'll run that, and then I'll hit save. So now that I've saved my notebook, I want to show you what NB Auto Export does for us. So if I go back to my terminal and I stop my Jupyter Notebook server, I can see that if I go to the notebooks folder and I list what's in there, I now have the notebook itself and also a folder called script. And if I go into that script folder, see what's in there, you'll see that I've got my summary statistics.py, and also I've got some untitled files for when I saved my notebook while it was untitled. Let me get rid of those, and NB Auto Export provides an easy way to do this. So let me go back and run NB Auto Export clean, and clean will delete anything that is not associated. And actually, I'm going to run this from my root directory, NB Auto Export clean notebooks. It will delete anything that's not explicitly tracked. So if there's not a matching notebook, it'll remove those extra files for us. So I'll run that. I'll say, do you want to delete your .git keep and these untitled ones? And the answer is yes, I would like to delete those. And it removes those for me. So now I can go about my analysis. And I happen to have been working on this project for a little bit. So I've got some work that's in flight. I, let's say, have already committed, like we saw, the initial version of the cookie cutter. And I've pushed that to GitHub and created a Git repository, Wildfire Tracker, that just has that initial cookie cutter. And now it's got some scraping things, but it doesn't have any of the notebook changes yet. So if I go to just this version that's a little further along, I can see that it's the same setup here. If I do git status, you'll see that I've got 3 notebooks that are in flight here that I'm working on. And we can take a look at those. And the first one is, like I said, Notebook 1.0. This is a data exploration notebook. In this, we'll see we look at some summary statistics from our analysis, and we create some plots. Here's one for the largest extent in acres of the reported wildfires. Here's the number of incidents by start date. You can see actually this mid-August one is associated with a lightning storm that happened here in California. And we can also look at the causes of these fires, investigate the fuels that the fires are using, and so on. So this one, Notebook 1.0, I would say is about ready for a code review. I've got some other notebooks in progress. So here's one that has an animated visualization that shows the fires over time as we have incidents that are reported, and you'll see August and September have been bad here in California and then up in Oregon and Washington. And I've also got some text modeling that I'm doing, trying to summarize the incidents based on the narratives that they present, you can see this one also probably needs some work. So I won't submit that for code review yet. Let's go back to the terminal, and I'm going to create a branch to house this work, and I'll call it Summary Notebook for now. Now, I want to add this Notebook 1.0 to this branch, and I'm going to add the PI file as well. So add the notebook, add the PI file. We can see those are ready to be committed. So I can do git commit. Here's that notebook, here's that PI file. And I'll commit the summary exploration notebook. And I'll push it to the same branch on GitHub. So now that it's pushed on GitHub, what I can do is see summary notebook. It changes less than a minute ago. So now I can compare and pull request. Here are the summary statistics. So usually it's the case that another team member would review this work and want to take a look at it, but I'm the only person here right now, and so I'll do my own code review for the time being. So you can see I've got a large diff for the IPyNB, and then I've got all the code separated out in this data exploration, just the .py version. So let me show you a couple things I do to make this workflow make sense for us. The first one is that I always go ahead and just click through for these IPyNBs that I've viewed them already, and that I don't need to see that loading diff. I just want to look at the code. And then the other thing I do is I click on these dots and I open in a new window the notebook itself. And what I like to do is have the notebook side by side with the code as I do the code review. And what this lets me do is look at the output that's generated by the notebook. So I can see the plots that are created, I can see the statistics that are reported, I can see the tables that are generated, and I can also look at the code at the same time. So whenever I'm reviewing something, and I usually do it on a larger screen, I've got the notebook code and the actual output side by side. So if I'm taking a look through this and I say, okay, we're investigating the causes of the fire. What are all the causes? What are the most common groupings? And how prevalent have they been this season? I can look through this notebook and read along. And I see that we take all of the incidents and we create these cleaned causes of the fires, and then we plot them. But if I look at this code, I notice there's an issue, and that is that each incident has multiple reportings. So it gets observed multiple times, and the larger an incident is, the more likely it will appear in this all incidents 5 or 10 or 20 times. So I happen to notice that there's an error here that we're probably overcounting lightning and unknown in these scenarios because they're associated with just one incident. So I think we missed doing a group by here. So let me go ahead and add that note as a code review in GitHub. So I go down to that line where I see it happening, and I see that we're just doing the value counts here for the clean causes. And I'd say, I think that we actually want to do a group by on incident name first, since this will count the same incident multiple times as is. And can start a review. And that comment will then be associated with that line of code, but I can also see the output there. So let's say that I was looking at this graphic of fuels, and I saw that it's missing a title. for something like this, I'd go to the place where this gets printed out, which is down here at this line of code, and I'd leave the comment, the graph here is missing title. We'll want that before we share it. Add a review comment. And through this process of having the code with the notebook side by side, it's very easy to track what the output is, what the input is, and then leave comments that are much, much easier for someone that is consuming this code review to then use. So if I submit this code review, when the person who wrote the code, still in this case me, comes back to it, they'll see these comments associated with those lines of code from the notebook, and it's very easy for them to find them and make the changes in the relevant part of the notebook. So that's our overall end-to-end flow for code reviewing Jupyter notebooks and editing them. So those are the core pieces of the process. First is the consistent project structure, so everyone who is working on the project knows where the code is. Second is the naming conventions, so we know what order things happened in within the notebooks and how that maps to our data science process. And we also name things by individuals. We only have one person working on a notebook, so we really do our best to avoid ever having to merge Jupyter notebooks. We didn't get to talk about refactoring, but that's a core piece of what makes larger projects work for our organization. I showed you the automatic export using NB Auto Export, and also the review process for the side-by-side IPython notebooks and Python script files. So I want to wrap things up by sharing a few other related tools just to give you an overview. The first is NBDime, which does notebook diffs and merges. It's a great tool, and it works really well for locally looking at diffs between notebooks. The big problem for us is that there's no real good way to integrate it with our code review process. So we can't use the GitHub interface to leave comments on particular parts of the diff so that we can draw people's attention to them. So that's the primary thing that or the primary reason we don't use NBDime right now. There's JupyText, which does a handful of similar things to NB Auto Export, where you can pair a script version, and you don't even need to commit the notebooks if you do JupyText. It sort of has this ability to reconstruct a notebook from just a text version. And this was a little more complicated than what we wanted to do for our use cases. We really wanted the simple tool that on save exported the Python version, and we could just track that. And so that's why we use NB Auto Export, which is a little simpler, but because it's simpler, it's less powerful than JupyText is. JupyText is definitely worth checking out as an option. There's a third-party service called ReviewNB where you can actually connect this service up to GitHub and leave reviews of Jupyter notebooks. There are a couple of downsides. The first is that it's not free for private repositories because it has to, be able to run as a third-party service. And you can't leave line-level comments in it. So it didn't really fit in our workflow in that a lot of our PRs contain both code changes to our Python source files in addition to changes that we've done in notebooks. And we want to be able to do our reviews in one place. So we don't use ReviewNB, but it definitely looks promising, and you should check it out as well. So thanks, everyone, for watching this talk. I hope it was interesting. I hope you learned about some tools you hadn't seen before, and you've got a better idea how to make Jupyter notebooks work for your organization and your collaborative process. I want to give a shout out to the JupyterCon organizers. It is a pretty incredible pivot that they've done, and they've been hugely supportive of the speakers, and I think worked incredibly hard to put together a great virtual conference, which I don't think is easy. So shout out to them. And then I also want to shout out the other contributors on NB Auto Export and some of our other projects who are team members at Driven Data, Jay Chi, Robert Gaboni, and Emily Miller. So thanks all. Looking forward to connecting. You can find me on Twitter or at drivendata.org. Thanks. Bye.